Hi, in this video we are going to talk about the concrete implementation of the bin packing problem. So let's get started. First we have three classes, the app.java, the bin.java, and the first fit decreasing algorithm.java. And of course the bin is just a class in which we are going to store the items. It's going to represent the bins, as you may guess. First of all, we will have an ID. It is just the name of the bin. Of course, we have the capacity, how many items it is able to contain. We will have a current size, because if we add items, new items to the bin, of course we have to track that what is the leftover empty space and so on. So we have to keep track the current size. And of course we are going to store a list of the items we are included in this bin. So of course in the constructor we are going to get the capacity and an ID, and we are going to instantiate the array list accordingly. Okay. Then it is the basic method, the put. It's going to return a boolean. We get an item and we check whether it is possible to put the item into the bin. And if the current size plus the item is greater than the capacity, of course it means that the item, we are not able to put the item into the bin. So we return false. And anyways, we just add the item to the items list. We update the current size accordingly to the item. And we return true, which means that we are able to put the item to the items list. In the toString, we are just going to iterate through the items list. It is just the items. And we are going to return the content of the bin, and I'm going to concatenate the integers. So what are the included items in this bin? And the first fit decreasing algorithm, we are going to store a reference to bins, an array list. Maybe I'm going to use x this dot bins, okay. This.bins is going to be equal to a new array list of bins. I don't have to specify it. And of course, we will have as many bins in the worst case as the number of items. So I don't want to create an infinite capacity, but rather the items dot size. Because if we have some items and all of the items fits a distinct bin, then we will have as many bins as the number of items. Okay. So we will have this solve bin problem method, and here, as we have discussed, first of all we have to use the collections.sort method on the items. These are the items we have specified in the constructor, and of course we have to use the reverse order because we want to start at the biggest element, and we want to get a decreasing order. If the items, after the sorting, the first item, which is the greatest item, is greater than the bin capacity, it means that there is no feasible solution. Because, for example, we have a capacity of 5 and we want to put an item with 10. Of course, we are not able to do it because 10 is greater than 5. So there won't be any feasible solution. Anyways, if there's a feasible solution, we just instantiate, this is the first bin. This is the first bin. Of course, there will be at least one bin, so we are going to create it. And we just iterate through the items as we have discussed. I'm going to store a flag, an isOK flag. I'm specify the current bin because we specify that this is the first bin. Okay, we start at 0, but anyways, this is the first one. And while is it okay, here in this while loop, we try to put the given item, the current item, into a bin. If the current bin is equal to the last item, so item doesn't fit in the last bin, it means that we have to create a new bin. Then that's why I'm going to instantiate a new bin with an incremented bin counter and of course the bin capacity. And we just put the current item, we add it to the bins list, and we set it the is okay to true because it means that we have already inserted it, so we don't have to iterate our algorithm anymore. Else this get current bin.put returns true, current item fits in the given bin. That's what we have seen here, that this is a boolean, and if we are able to put the given item into our items list, we are going to if we are not able to put our item in our items list, we are going to return false, and anyways we're just going to put it and return true. So if it's true, it means that we are able to put the item to the given bin, so we don't have to instantiate another bin. And of course we terminate our algorithm, so that's why is okay will be true and its negate will be false, so we are going to quit this while loop. And anyways, we just try the next loop, the next bin. This is the algorithm. We sort our items in a decreasing order, and we always try, is it fit into the first bin? No. Then we go to the other. Is it fits to the next bin? No. And if we get to the last bin and we come to the conclusion that it is not fit there, we just create a new bin for it. So this is the algorithm. And of course here the show results, we are going to print out the bin content. We just system out the bin, and because the bin overrides the toString method, we are just going to get the items in the given bins. So for example, we have 10, 5 and 5, and the capacity is 10. Of course there is a feasible solution. We have two bins, the first bin containing the 10 and the second bin containing 5 plus 5. Is it feasible? Of course, because the capacity is 10, it contains 10, and the second one contains 10 as well. If the capacity is less, for example, we have capacity is 4 and we have the items 10, 5, 5, you may guess that there won't be a feasible solution. We are not able to put 5, let alone 10, to a bin capacity 4. So the result should be no feasible solution. Okay, we have, for example, 5, 5, 5 as items, and the bin capacity is 5. Then there will be 3 distinct bins. So this is how we solve our bin packing problem. Thanks for watching.